Bismillahirrahmanirrahim. In this part, we are going to speak about the verification of trigonometric identities. To start with the definition of the word identity first, then we go for the verification. Identity, it is a type of equation. For the equations, we have three types, or I can say three cases. The first one, if we have, for example, 2x minus 1 equal to 3, then x will be 2. The solution for this equation, x equal to 2, or we can say this equation is true only if x equal to 2. If x is not equal to 2, then this equality is not true. We call this type of equation conditional equation. It means it is true in one condition, that x is equal to 2. So this is conditional equation. The other type, if we have x minus 1 equal to x plus 3, this will imply minus 1 equal to 3. But we know that minus 1 is never equal to 3. We call this contradiction. Contradiction, it is an equation or just expression which is not true for any value of x. So there's no value for x makes this equation true. The left-hand side will never equal to the right-hand side. We call this contradiction. Third type, if I have, for example, x squared or x minus 1 squared is equal to x squared minus 2x plus 1. Actually, this is true for any value of x. This is true for any value of x, or it is always true. This type of equation is called identity. So the identity, it is an equation which is true for any value of the variable x. Whatever is the value, the left-hand side will be equal to the right-hand side. And the trigonometric identity, it is an equation contain the trigonometric function, sine, cosine, tangent, cotangent. And for the verification, it means we need to show that the left-hand side equal to the right-hand side. So the idea of this topic is to verify, is to show that the left-hand side is equal to the right-hand side. And to do this, we need some fundamental identities. We have some identities or trigonometric identities. First type is reciprocal identities, which is sine x equal to 1 over cosecant of x. Cosine x equal to 1 over secant of x. Tangent of x equal to 1 over cotangent of x. These are the reciprocal identities. Rational identities. For tangent, it is sine over cosine. For cotangent, it is cosine over sine. These are the reciprocal identities or ratio. Sorry, this is the ratio identities. Third type, Pythagorean identities. Sine square plus cosine square equal to 1. Tangent square x plus 1 equal to secant square, and 1 plus cotangent square x equal to cosecant square. These are Pythagorean identities. Last one is odd even identities. Odd identities, the first one, it is that when we remove this x to be in the front of the function, sine of minus x equal to minus sine x. The negative with the angle x will be the coefficient minus 1 multiplied by the function sine x. This type we call it odd function. And we have tangent minus x equal to minus tangent x. Cotangent is minus cotangent. Cosecant is minus cosecant. These are odd identities. For the even identity, remove this color. For the even identity, when there is no change, cosine minus x equal to cosine x. These are even identities. cosecant minus x equal to secant x. So secant of minus x equal to secant of x. These are even identities. So we have odd identities and we have even identities. To give more details about now the verification of the trigonometric identities, let's have some examples. I'll go through these examples to show or to verify the left-hand side equal to right-hand side. In general, for the verification, in general, we have one side of the equality is more complex than the other side. We'll take that one and we will try to simplify it. So for example number 1, we have tangent x, cosecant x, cosine x equal to 1. Let's speak about the exercise number 1. So I will take the left-hand side because it is more complicated than the other side. The left-hand side, this is LHS, means left-hand side. We have tangent x multiplied by cosecant x multiplied by cosine x, which is equal to, now tangent, if we use the ratio identities, it is sine x over cosine x multiplied by cosecant is 1 over sine x multiplied by cosine x. Now this sine will cancel this sine and cosine will cancel this cosine. I will have 1, but 1 is equal to the right-hand side. This is the right-hand side. So we can say that we verified the left-hand side is equal to the right-hand side, and we didn't speak about the values of x. So this is true for any value of x, and that's why we call it an identity. Let's take example number 2, tangent x. Second example, tangent x multiplied by secant x by sine x equal to tangent square. Example number 2, we have tangent x multiplied by secant x multiplied by sine x equal to tangent square. We need to verify this identity. Let's take the left-hand side. Seems to be more complicated than the right-hand side. We have tangent x multiplied by secant x multiplied by sine x. Tangent, I will leave it as it is because I need tangent x to be there on the right-hand side, so keep the tangent x as it is. Secant of x is equal to 1 over cosine of x multiplied by sine x, which is equal to tangent x multiplied by, now sine multiplied by 1 will give me sine over cosine x, but sine over cosine is equal to tangent. So this is equal to tangent x multiplied by another tangent, which is equal to tangent square. And this is the right-hand side. So we verified that the left-hand side equal to the right-hand side. Next one, say example number 3. We have 4 sine square minus 1 over 2 sine minus 1. Question number 3 or exercise number 3. Over 2 sine x minus 1 equal to sine x minus 1. This is the plus down. So I need to show that 4 sine square x minus 1 divided by 2 sine x plus 1 equal to 2 sine x minus 1. I will take the left-hand side. We can take the right-hand side also. But I will take the left-hand side because it is be more complex or complicated than the other side, the right-hand side. 4 sine square minus 1 divided by, now 4 sine square minus 1. It is difference between two squares. If I have a square minus b square can be written as a minus b multiplied by a plus b. So I will use this identity. It is difference between two squares. We have a square minus b square equal to a minus b multiplied by a plus b. Now 4 sine square minus 1, this is difference between two squares. So it can be written as 2 sine x minus 1 multiplied by 2 sine x plus 1 divided by 2 sine x minus 1 or plus 1. This is plus. Now we have common factor. I have 2 sine x plus 1, but 2 sine x plus 1 will be cancelled, so I will have 2 sine x minus 1, which is equal to the right hand side. So it is already now verified. I have one more. Number 4. Question number 4, or example number 4. This sine square minus 2 sine x plus 1. Question number, or exercise number 4, we need to verify sine square x minus 2 sine x plus 1 divided by sine x minus 1 equal to sine x minus 1. Taking the left-hand side, that is, we have sine square x minus sine x plus 1 divided by sine x minus 1. For the numerator, we have sine square x minus 2 sine x plus 1. This is perfect square. Using the identity a square minus 2 ab plus b square, this is equal to a minus b all to power 2. This is perfect square. Or I can complete square. I have sine square. A is equal to sine. A is sine. 2ab, this is 2 is there, and I have sine x multiplied by 1, and b is equal to 1. So the numerator can be written as the identity, use it. So the numerator is equal to, I can write it as sine x minus 1 all to power 2 divided by sine x minus 1 down. So I can cancel the denominator with the square. I will have sine x minus 1. And this is equal to the right-hand side. One more example. Question number 5. Sine x minus cosine x multiplied by sine x plus cosine x equal to 1 minus 2 cosine square. I will take again the left-hand side. For the left-hand side, I have sine x minus cosine multiplied by sine x plus cosine. For this one, I will use the identity A minus B. Use the scalar for this one. I will use A minus B multiplied by A plus B, which is equal to A square minus B square. A minus B times A plus B is equal to A square minus B square. So the left-hand side will be, I have sine minus cosine, sine plus cosine. It is similar to this identity, A minus B and A plus B. So the right-hand side will be sine square, or if I write it as sine x minus cosine multiplied by sine x plus cosine x, this is equal to the first one square minus second one square, second term. So it is sine square minus cosine square. But also we know that sine square x plus cosine square x equal to 1. Sine square plus cosine equal to 1, or I can say sine square equal to 1 minus cosine square. So I'm going to replace sine square by 1 minus cosine square. So sine is equal to 1 minus cosine square x minus cosine square. Now minus cosine square and minus cosine square will give me minus 2 cosine square. And this is the right-hand side. It's done. So it is 1 minus 2 cosine square x, which is equal to the right-hand side. So we verified that the left-hand side equal to the right-hand side, which is 1 minus 2 cosine square x.